Alright, this last problem is going to be pretty challenging, I think. So what you want to do first here is notice that unlike in this problem where you had x's and z's in the first term and y's in the second term, here we have x's in the first term and the last term. And when you see it in the middle term as well, that means you have the same variable in every term. It can be factored out. So that's the first thing we want to do. But it's going to be tricky to factor with all these fractions here. So it'd be easiest if first thing we do is rewrite everything with negative exponents, since everything's all over the place right now. And while we're at it, we might also want to factor out a negative in front of for the whole expression, because we don't want to have that in front of the leading term when we eventually end up factoring. So this is going to be negative 7x to the negative 3 minus, or plus now, since we're switching all the signs, since we factored out the negative, plus 4x to the negative 1, y to the 5th, minus, we flip that sign, 36xy to the 10th. Okay, factor from here. What do we see? We have x to the negative 3, x to the negative 1, and just x to the first. So negative 3, negative 1, and 1 are all 2 apart, which is good because that means we will eventually end up factoring the x's. But the first thing we want to do is get rid of negative exponents. So to do that, we're going to get this one up to the highest non-negative, which would be 0. So we have to increase all of these by 3, which means we factor out of the whole thing an x to the negative 3, or 1 over x to the third. And if you'll notice, y is only in these last two terms, so we can't factor that out. So we're just factoring out an x to the negative 3. And make sure to bring down the negative sign in front of the whole thing. So now increasing all of the x exponents by 3, we end up with 7 plus 4x squared y to the 5th minus 36x to the 4th y to the 10th. And now we can factor with the coefficients 7, 4, and negative 36. So factors of 7. And now we got to find the right factors of 36. There we go. That's negative 14 plus 18 is positive 4. So now we have in front of the whole problem negative 1 over x cubed. Actually, doing what we did in the other problems, let's just put just the negative in front of the whole thing. And then put everything that we're factoring in the numerator, since it's being multiplied by just 1, all over x cubed. So what are the variables in these factored terms? Well, it's going to be, here we have nothing, so the first term is just constants. And then in the second part of the terms, it's going to be x squared y to the 5th. So here we just have 1 minus 2x squared y to the 5th times 7 plus 18x squared y to the 5th. And this whole thing right here, this is the final factored expression. Actually, if you really want, you can go one more step switch the order of these two terms, since it's usually neater to have all the variables in front. And if you want to switch the order of these two, you would need to factor out another negative, since you have this minus sign here. So you would have 2x squared y to the fifth minus 1. And in factoring out another negative, this would disappear. Now, there's just one more step we can do here, and that would be, just to make this problem a little bit neater, it's already factored. What we can do is reverse the order of each of these terms so that the variables are at the front part of them. When you have a plus, we can switch the order without a problem. It doesn't affect anything. But when there's a minus, we need to factor out a negative from the whole thing, so that we'll have positive 2x squared y to the fifth minus 1. But notice, if we factor out a negative, meaning this whole thing is being multiplied by another negative, the negative times this negative here goes back to a positive. So it ends up being a lot cleaner because we get rid of this negative in front of the whole thing. And now we have all the variables in front on both terms. And this right here is the simplest we can get with this problem. Alright, that was a pretty hard factoring problem. You're normally not going to see anything that complicated. But we do have more factoring. In the next video, we're going to look at another method for factoring higher degree expressions. This time, if we have polynomials that are not binomials, trinomials, they have 4 or more terms.